It's on. Self-test 2, hardest problem. So guys, out these self-tests, I like to reflect like, how did you do on those ones? Were they hard? Were they easy? Because again, I compare kind of the self-test to about the level of difficulty of the fall final. So it's kind of a good gauge of where you're at. You'll notice that the problems are generally a little bit easier, I'd say, than a lot of the B-level problems under the normal problem sets. Because again, you've tried some harder things out. Now you're pulling it back, being like, how did I actually do? So a lot of people actually mentioned this was the hardest problem. Some people said that none of them were too hard, but they had to pick one. They would pick this one here. But most everyone said there's at least one hard problem in the self-test, which is totally fine here. So we're going to do this one together right now. Word problems, right? Word problems. We definitely know that as math teachers, right? We talk about it. Word problems harder for folks, right? It's not just the numbers, but it's also words. So you're reading and flexing kind of your number skills here. So on a problem like this, you really want to go back to what I told you in the lesson video and what any algebra teacher would tell you. Because again, I'm an algebra teacher and I'm also a geometry teacher here. When you have a word problem, start by defining your variables. So let x equal the measure of the angle. Let 180 minus x be the measure of the supplement, right? This is why I did all these examples with you guys, because it should be pretty quick to set it up this way. And let 90 minus x equal the measure of the complement of the original angle. And once you get it set up like this problem isn't super hard. Sorry, measure of the complement here. So this is really why I put pressure on you guys in the video, right? Showed you several examples we went over the next day in classes, because once you have kind of your variables defined, then that's the easy part, right? We have it defined, but a lot of people don't know how to do that right away. Then the next step becomes writing this out as an equation right here, okay? So the measure of the supplement of an angle, so we'll start talking about that first. That's 180 minus x. Of an angle is, we have the is there. Remember, is equals, okay? So definitely in Algebra 1, should have covered that. If not, you're getting it now. It's what math's all about, right? Going forward and also looking backwards here. Is an equal sign if we're actually translating a word problem into an equation here. Is 4 times as large as the measure of the complement of an angle. So 4 times as large as the complement of an angle, and we know that complement of an angle is going to be what's left over once we take away that angle's measurement from 90, and then we're good to go. Got ourselves an equation. Very nice. That wasn't too bad here. I've done problems like this quite a bit, though, anyways. So you just need to see examples, and also realize defining your variables, right? Follow those steps. Step 1, define your variables. Step 2, write out what's being mentioned here. Replace is with equals, and you're pretty much good to go. You might have to reason through it a little bit, but this one isn't too much reasoning right here. So now find the measures of all 3 angles. We can solve this one here by solving our equation. Let me move it down here so you can actually take a look at the solving stuff here if this is where you're running into problems here. I wouldn't divide both sides by 4. That would be silly because I'm going to be dividing x by 4 here. So I'll use the distributive property of multiplication over division. Distributed that 4 to the 90. Remember, parentheses means multiply, and we have 2 different terms here, 90 minus x. That means 4 goes to 90, and 4 also goes to negative x. For those of you who are in Algebra 1 right now, you will review the distributive property very, very soon. So we get 180 minus x is equal to 4 times 90. You're going to get faster at mental math like this year for sure, because you have a lot of 90-degree angles, right? Right angles, complementary angles, add up to 90. 4 times 90, 4 times 9, of course, is 36. Tack a 0 on there. That's 360, actually, right? 360 comes up a lot in geometry, too. 4 minus times negative x is going to be negative 4x right here. We've distributed. So now we just need to solve for x, and that's going to be the measure of the angle. We can do that next. So next step, if you're in Algebra 1, perhaps you're reviewing this as well, but I would collect my variables to one side of an equation. So I had negative 4x over here, so I'll add 4x to both sides so as to make sure that I have a positive number of x's on one side. So now I got 180 negative x plus 4x brings us up to 3x's. And right, we made a 0 over here because we wanted to collect variables to one side of the equation. And then that's going to be equal to 360. Now I can isolate my my variable expression. So I want to get 3x by itself. That would be the next step to solving an equation like this. So I'll get rid of that 180. Inverse operation right there. I will subtract 180 to make a 0. 360 minus 180 is going to equal 180. And then we have 3x here. So maybe this is at this point, if you had not too much trouble at all at the self-test, you're just like, well, this was a lot of steps. This took me a while to do, and I understand that. It takes a little bit here. Okay, so operations, I guess I'm doing my operations to both sides. We'll use the division property of equality. Check it out here, dividing both sides by 3, right? When we have an equation, if we do the same thing to one side equation as do to the other side of the equation, we know that equality will be preserved, and that'll be a property of equality. This is the division property of equality here. 3 divided by 3 is 1. Shouldn't have crossed out that 3 there because 180 divided by 3, right, would go into it 60 times. So x equals 60. Boom, we got one of our answers. So this is 60 degrees. And then this is 180 minus x, and x, remember, is 60 degrees. So that's going to equal 120 degrees. And finally, 90 minus x, and remember, x is 60 degrees, and it's going to be 30 degrees here. And our answers make sense. Always think back, do your answers make sense? Well, yes, they totally do. We have the angle at 60 degrees. So its supplement should add to 180 and 120. Sure, that gets to 180. And your complement should get to 90. So 60 plus 30 is 90. And you're good to go there. So we found the measures of all three angles, and then you can quickly check in your minds. The measure of the supplement angle is 4 times as large as the measure of the complement of the angle, and that would check out too. 30 times by 4 equals 120. So sounds like we answered the question, right? I don't see any issues here. It seems pretty airtight to us here. Okay, so hopefully this helped out a little bit, but remember, okay, remember your notes. When you get problems like these, first step, define your variables, right? As I was telling you in the lesson, that you got to define your variables. And it's very simple. X equals the measure of the angle. 180 minus x is its supplement. 90 minus x is a complement. Boom. You have something that goes with the words that go in here. Okay, and then you got to write equation, right? Your equation using your variables and using kind of the operations being mentioned here like 4 times. And remember that is means equals, right? Equal sign, okay? And then you got to solve for all measurements. And then you're good to go, okay? So we don't have too many more of these practice problems left. I've pretty much given you almost all in the book. So feel pretty confident on it. You're ahead of the game, right? Ahead of the game. So again, you might see questions like this on the SATs in the future, but keep in mind that's several years away for you guys here. 10th graders, maybe a year and a half is probably the first time you're going to take it. So just know that geometry is going to get you in a position to kind of have a sense of how to do problems. But again, you'll be, if you really want to do really well in the SATs, you're going to be practicing a lot of problems like these, getting your SAT study guides and whatnot. And these types of problems will be on those study guides for sure. So I'm sort of getting you started with it, and hopefully you understand a strategy to solve it. If you don't feel 100% on it, just keep practicing, okay? You'll get there before the SATs, and if you know how to solve this one, you'd be able to do a question like this on a test, and I have confidence with you guys on it. All right? Ask me any questions. Feel free to email me, or that's the best way to get in contact. I'll see you guys later. Bye.